We'll go ahead and get started here. It's one. Thanks for coming out to the talk. My name's Doug Campbell. I'm a senior DevOps engineer at GoGo. If you've not heard of GoGo, we're the leading provider of in-flight internet and other like connected aviation type products. And I'm going to be talking about continuous delivery with Spinnaker. So just a brief overview of what I'm going to talk about. I'm going to go over like continuous delivery. What is continuous delivery? What are some of the benefits of that? How we do continuous delivery at GoGo. I think we've got a pretty great model. We do 5,000-ish deployments a month. And I'll go over how we accomplish that. And then I'll go over Spinnaker, what Spinnaker is, Spinnaker versus some of the other major players like Jenkins and GoCD. And then I've got a live demo set up. I'll show off what Spinnaker looks like at GoGo, like what we're an AWS shop, so what our AWS deployments look like and how we accomplish that. But I also set up a demo in Google Cloud Kubernetes engine using like Google Container Registry, doing all the Google-y things since this is a Google event. So continuous delivery. If you've not heard of continuous delivery, it's kind of what it sounds like. It's continuously delivering your applications. Delivering your applications in an automated, reproducible manner as often as you're making changes, more or less. It doesn't necessarily imply you're continuously delivering into production. It could be a continuous delivery into a dev or staging environment, though a lot of companies are doing straight to production. And if you have good metrics and good testing, it's a pretty awesome model. These are some of the core tenets behind what continuous delivery is. First and foremost, automated reproducible deployments. You can't really have continuous delivery without automated deployments. The idea is that every time your developers make a change set or push a new tag or push to master, it doesn't have to be every single line of code. Your application gets built in some reproducible manner and deployed to some environment that they can then see the status of their application. You need to make deployments boring. And a lot of legacy systems, deployments are a thing. They're something you plan. They're something you have to engage other teams with. But in a continuous delivery workflow, deployment should just be a very standard part of any development process. You push code, you get application. They need to be boring. They need to not be something that's really even thought about too much. You need to have a good continuous feedback cycle within any continuous delivery model. This is where Spinnaker comes in. I'll show you Spinnaker. You'll get a good idea of that. But there needs to be constant feedback to the development teams that your deployments are successful, what the failures were, where bottlenecks are, what versions are running where, what versions you have available to roll back to, things like that. There needs to be great feedback and continuous feedback within a system like that. Immutable infrastructure. If you've not heard of immutable infrastructure, it's basically the idea that once your infrastructure is up and running, you don't change it. If you have changes, you destroy it and recreate it. You're never SSHing in and changing a config. You're never mucking around in the AWS UI to like change any of your things. It's immutable. It doesn't change. You redeploy to get something new. And within any continuous delivery system, testing needs to be a first-class citizen. It needs to be thought about from the very beginning and needs to be very integrated with the system. If you're deploying continuously, you need good tests that your deployments are successful, that your application is running as expected. And as you build up that testing system, that's how you get to like this idea of continuously deploying to production. If you can deploy out to like a canary in production that 5% of your users get and test against that and have solid metrics, you can start to trust those deployments a lot more and just deliver straight to production and know that you'll catch failures early and often. Some of the benefits of doing continuous delivery. First and foremost, you get fewer bugs with lower risk deployments. This sounds somewhat counterintuitive to people that haven't been part of like continuous delivery systems before. But if you think about it, you're deploying much smaller change sets. You're deploying just those changes that happened since the last time you deployed. So like, in a lot of cases, our developers are deploying their applications 20, 30 times a day, some even faster depending on their deployment cycles. And so each change set that you deploy is much smaller, so much fewer bugs are introduced with each deployment. This makes each deployment itself lower risk. And if you do introduce bugs, you know that much smaller change set, and you can find where the bugs were much quicker. And they're also lower risk in the sense that they're automated reproducible. You can roll back to the previous version that was working if something's failed much quicker than like a legacy system where you've had to go talk to an operations team and say, here's my code, please deploy it, and something breaks and the operations team has to go back to a development team and say, hey, your application broke, and they're like, no, it's your fault. So it makes deployments just lower risk, fewer bugs introduced with each deployment, and quicker catching of them. The obvious benefit is release new features faster. If you're deploying as soon as a feature's done, not waiting to some arbitrary bi-weekly release date, once a month release date, those features get out when that application development team is ready for those features to get out. In a lot of cases, that is much faster than following some standard cycle. Quicker feedback, so that means you get less late night alarms. If you've got good feedback cycles over how the test failed, what metrics came out of this, stuff like that, you can view that feedback much quicker. You can roll back to a working version before you leave for the office for the day. You get less late night alarms. You're doing much less I've worked at companies before where you only did deployments at 7 p.m., which means if something broke, everyone was up for a while fixing that. In this case, it should just happen during normal business hours. And there are always business use cases where there's one application that people don't necessarily trust well, so they only deploy it late at night, and that's still acceptable. But at least you've got a good testing system in place, so you can still catch those when you're doing them late at night and not be up as late. You end up with less reliance on other teams. There's no engaging an operations team to get a deployment done, or working with the release team and hoping communication doesn't fall apart. The application development teams in a good continuous delivery system should be as self-service as possible, and they should be supporting their own deployments and getting their own alarms. This has been somewhat of a hard one for some of our developers in that they don't want to get alarms, but it's your application, and if you own the whole cycle the whole way through, it just makes it easier on everyone else. And that all leads to kind of a shift in the organizational culture. That's where the whole DevOpsy buzzword comes in. Continuous delivery is part of that DevOps culture, and making each team as self-reliant as possible, stopping the blame game of operations broke my deployment. If the development teams own their own deployments and get their own alarms, everyone improves, and there's no one else to really blame but your own team. And then by all of this, you kind of increase and improve focus on metrics and testing. You see that when you have good tests and good metrics, you can trust your deployment so much more and relax that it's continuously deploying. And so everyone works together to improve those tests and those metrics to continue to improve confidence within the deployments. So here's kind of how GoGo does continuous delivery. We do about 5,000 deployments a month. That's not all to production. I think we're probably more around 1,000 a month to production, if that. But this is the different stage, dev environments, compliance environments, things like that. The big tools we use are Jenkins for the CI part of things, and Spinnaker for the continuous delivery part of things. And this will kind of make sense too as I show off Spinnaker on my demos. Step one, developer pushes code. Most of our use cases, we're only watching the master branch within Git. Some are only triggering off new tags. Within our system, you can't technically trigger off a branch. But we'll just assume they push their code, their changes to master, whether that's through a review process or whatever. That's all up to the development teams. We don't care. Developer pushes code. Jenkins sees change in code. It builds out the code like any CI system does, builds, runs unit tests, does all that stuff. And ultimately, we build out our deployable artifact, which is an RPM in our case. We upload the RPM to Artifactory, and that's kind of where Jenkins stops. Spinnaker is constantly monitoring that application's Jenkins job. It sees a job was successful, Spinnaker triggers its pipeline. Spinnaker, we're in an AWS shop, so Spinnaker first builds out an Amazon machine image, which is what now will be deployed the entire way through the pipeline. That one image, we'll never rebake it through dev stage prod. It bakes out that image from the artifact that was built from Jenkins. And then Spinnaker goes and generates all of our AWS infrastructure for us. It generates our load balancers, our security groups, our IAM permissions, anything it really needs. In some cases, the databases or an S3 bucket. And then it takes that AMI that it built and deploys it to the first environment that our developers have configured. Say it's a dev environment. Deploys that AMI out to the dev environment and its auto-scaling group, puts it behind the load balancers previously generated. The whole time, Spinnaker has a really good insight into AWS. It's communicating what resources exist, what stage of the pipeline it's on, where maybe a bottleneck might be. Spinnaker sometimes will get stuck in this waiting for cache refresh state, which means you're probably getting rate limited by AWS. But you've got this insight into why something's taking a while or at what stage it's at. And then we go down, we run QE checks, which are quality engineering for us. It's our automated test. It's automated testing against that infrastructure that is just generated. And then At this step, it kind of waits for manual input. It waits for someone to click continue or stop. If they click stop, it stops here. It was continuously deployed to that first environment, dev, stage, whatever you want it to be. If they click continue, it does the exact same thing in the next environment that the development teams have configured. And it just kind of repeats that cycle of generate AWS infrastructure and run quality checks. That's how our general workflow works. It seems like most companies that are doing continuous delivery have a pretty similar workflow. Tools differ. There's no necessarily right way to do this by any means, but this works very well for us. So now Spinnaker. Spinnaker is what we use to facilitate the whole continuous delivery part of this, especially like the cloud resources and stuff like that. Here's an overview of what Spinnaker is, some of the features. As I go into the demo, some of these will kind of click a bit more of what they're actually doing. Spinnaker is first and foremost designed for continuous delivery. It's not a CI system. It's not like a cloud management system. It's a continuous delivery system, and that is what they've built for it to do. It was developed by Netflix originally. It was used internally at Netflix for 2 or 3 years before they open sourced it. We're talking about this at a Google conference because Google has a very large role in it now. Google saw a lot of potential in this. Google added all the abilities to do like Google Cloud Engine or Google Compute Engine, Kubernetes. They've added a lot of support for like Google Storage as a persistent store within Spinnaker. Google's written all the docs as well. If you go to the Spinnaker docs, that was all by Google. They've got a really large hand in this now. They don't actually use it internally as far as I know, but Google has seen the value of promoting Google Compute Engine and Google Cloud via Spinnaker. And so that's why they do a lot with it. Spinnaker allows for highly customizable pipelines. You'll see this again, but you can build out pipelines that pretty much fit any organizational need. And pipelines that just like run a Jenkins job and then run some web service and then do a deploy step and then create a new load balancer, and pipelines that do a bunch of things. It's got built-in deployment strategies, meaning like when you're deploying a new application, you can say, I want this to be a blue-green deployment that will spin up your new cluster and disable the old one, but keep it all running. So that if the case you need to roll back, it's pretty much just like a swap. Or you can do like all or nothing, where it just like spins up the new one, once it passes health check, destroy everything else. You can build your own custom strategies as well. They're kind of like sub-pipelines that say when it's time to deploy, do all this sub-pipeline stuff as well. It's got a lot of integrations from a cloud perspective, Google Cloud, AWS, Kubernetes, Azure, OpenStack, DCOS, Oracle Bare Metal Cloud, which I guess is something people use. It supports a lot of those things, and it's all open source, and a lot of companies seem to come into Spinnaker and add new ones all the time. I know there's stuff coming for like App Engine and some of the more like platform as a service type things too. Integrates to a lot of standard CI systems, Jenkins, Travis. I put Docker registry under CI. That's mostly just like a pipeline trigger. So like if you're using something like Drone that's not directly supported, if you're doing containers, it can just monitor any Docker registry and use that as its entry point to Spinnaker. From an auth system and like enterprisey things, LDAP, OAuth, SAML, GitHub groups, and you can do like group-based permissioning that like only people in these LDAP groups have access to these applications. And that's really nice. We're a public company that does PCI and SOX compliance, so we have to have a lot of those things that say allows you to track who made changes to what piece of the infrastructure throughout the whole process, and who approved deployments into prod if it's a SOX application, things like that. Spinnaker is designed to be multi-region and multi-cloud. We do deployments to multiple regions in AWS through this, all through one pipeline or like a clone pipeline that you just swap what region it's going to. You could do multi-cloud deployments too if you wanted. It would be pretty straightforward to set up a deployment that deploys your application to Google Cloud and AWS, which I know companies that are actively doing. Like I said, it's all open source. It's mostly written in Groovy Spring Boot, but it's a well-maintained code base. It's relatively clean. They are very active on their GitHub stuff. It's under very active development. Changes come in all the time, which used to be a problem. They used to move at a very fast pace that made updating hard. They would break things. When Google got involved a lot heavily, Google really solidified their deployment process, and now Spinnaker has like official releases, which is really nice. and has been much more stable since Google has been involved in the actual release process of Spinnaker itself. Large active community. They just had their first summit at the Netflix headquarters. Probably about 400 people attended. They're going to have yearly summits. They are active on Slack, on GitHub. Really great community to interact with, and the engineers are always willing to help. Great API. We've written a lot of tooling around Spinnaker. All of our pipelines are generated through their API, not like this point and click UI. That's also great, but we've done a lot with the API. We've open sourced some tooling around it too. There's a CLI configuration tool called Halyard. We don't actually use it. I can't really answer any questions about it. Google wrote it, but it's basically a tool that says here's all the clouds I want Spinnaker to connect to. Here's where my backends are. Build it, and it'll deploy out Spinnaker for you to your configured cloud. It'll handle the rolling updates. It'll handle a lot of the Spinnaker infrastructure. It looks really great if you're a newcomer to Spinnaker. And if you're thinking about getting started, definitely look at Halyard. All their docs reference it too, so it would be hard to miss. Whenever I've talked about Spinnaker or done similar things, I get, what about other tool? What about Jenkins pipelines? What about GoCD? What about Thing? I quoted Thomas Lin. He's one of the main engineers on the Netflix team that wrote Spinnaker. Someone asked this exact question in Stack Overflow, and he said, the thing that Spinnaker tries to do well is take a piece of software that you've published and run it through a predictable software deployment cycle that is highly customizable. That's Spinnaker's core mission. Its core mission is CD. So, with Jenkins does a lot of things, has a lot of plugins, has no real opinionated way of doing things. It's a great tool. It would absolutely work for continuous delivery. But Spinnaker has this very strong focus on just continuous delivery and cloud deployments. So Spinnaker takes an opinionated cloud-centric view on a lot of things, and it forces cloud best practices on you that Jenkins doesn't necessarily do, or some of these other tools don't necessarily do. For some organizations, that doesn't work if you have weird workflows and stuff like that. But I'd say for 95% of cases, it does. And that their opinionated view is a really great way to be doing things. And it does allow for customizability, of course. It's also got a really nice UI, which I'll show off, of course, to provision and monitor your cloud resources. You could lock down access to your entire AWS console or Google Cloud Console and use Spinnaker for all of the resource management for your development teams. It gives you a lot of really great metadata, a lot of really great control, and a nice central UI that would be placed right next to your delivery pipelines. And just briefly, here's what the actual Spinnaker applications architecture looks like. It's a group of microservices. There's a growing number of them. There's even a couple that aren't included in this graph. They've added a new dedicated monitoring microservice. And not all these microservices are necessary either. We don't run Fiat. Fiat is the group-based permissioning one. We do it a slightly different way. Fiat wasn't around when we got started. It does require Redis. That's the one backend piece of infrastructure it does require. It can also sort of require S3 or Google Cloud Storage, some persistent bucket type storage, though you can technically use Reddit for all that, but it's supposed to be for data that's much more persistent than Reddit gives you, or Redis, not Reddit, Redis gives you. You can scale each service independently. A lot of them are heavier than others. Cloud Driver is the service that actually reaches out to your cloud provider, be it Kubernetes, AWS, or whatever, and gets all that information back. That's a pretty heavy one. We run one for each account we're deploying to, and we run them on pretty big instances because it's beefy. But then things like Igor is the service that reaches out to your CI provider and gets information about that. That one's really minimal. You can run on a tiny instance. It's super stable, so you can really scale these out and change how they're done. It looks complicated because it is a relatively complicated application, but it's very stable, it's very well supported, and it all makes a lot of sense. They're definitely following good design practices with this, and they're keeping things as, they're following microservice best practices. We deploy Spinnaker through Spinnaker. All of these separate microservices are applications we have in Spinnaker. And we can update, this gate service independently of all the others without any downtime at all because it's going through a standard Spinnaker deployment cycle. So now my demo. I'll explain that out a little. So first I'll show off GoGo's Spinnaker, how we have this set up for our AWS deployments, what our actual pipelines look like. what options we get from that. I also have another demo set up where Spinnaker is running in Google Kubernetes Engine, deploying to that local Kubernetes cluster, and I'll do like an actual deployment through that. So this is Spinnaker at GoGo. You can see I'm logged in with like my corporate credentials. Any action I take in here will be logged. That D. Campbell at GoGo Air took that action. This is really great for our auditors. I deal with them all the time. They love it. You can see all my applications. I can click on applications, and we've got, I think, about 300 unique applications deployed through Spinnaker. You can see them all come up. I know what maybe 1% of them do. But I'll look at this Edge Forest application. This is a Java Spring Boot application we have. It's one we use for a lot of our testing and deploying up to the pipeline and stuff like that. So first view it comes on is this cluster view. These are all my running clusters across all my AWS environments against dev, stage, production. These are different AWS accounts, completely segregated from each other, but I get a nice view of what's running in them. I can see in dev I'm running build 256, prod 254. And if I click on this, it brings me to the Jenkins job 226 that actually like generated that artifact that was deployed. If I'm clicking on this top view here in dev, I get a lot of information about my server groups. I get what my capacity is, health, what images are deployed, stuff like that. I can take action on that server group. I could resize it if I wanted. I could change it to like 3. This will take, I'm not going to sit here and wait for it to spin up. It'll take about 3 minutes because it's an EC2 container. It's got to wait for it to pass health checks. But we'll go back to the view eventually, and you'll see 3 of these little green squares in dev, which is an instance. I can click on specific instances. I could, terminate, remove from my load balancer, all that good stuff. I can see what tags are on that instance. I can even view the raw console output, or like we set up links on these. So if someone wants to tail on like a logger, I can click on that and go right to the logs of that instance and do a live tail on those without anyone ever needing to SSH or anything to them. You can click on load balancers. This view is a little different. Well, on the screen, you can click on load balancers up here and see what load balancers that application is using and what server groups are behind each load balancer. I could create a new load balancer from in here if I wanted to. I'm not going to go through all that, but it gives you the ability to like even create load balancers that application can then use. What security groups it's using. Can click on a security group and get more information. You can see I've got US East 1 and US West 2 security groups, so it's viewing this application is only deployed in one region, but it's been deployed in 2 regions, so it like associates all those with it. You can pick that up if you want. You can add new inbound rules, and you can pretty much control a lot of your cloud resources through this across multiple AWS accounts. As many accounts as you configure, really. I think we have 7 different accounts for different compliance reasons. But the pipelines, this is kind of the bread and butter of Spinnaker, and where the continuous delivery parts come in. So you can see here's like the history of my pipeline executions. Here Jenkins was build 225, can click on it like the other stuff and see Jenkins build or 525 and what happened there. This one up here is 256 or 226, 526. And you can click on like what happened during what stage of the environment, like during this infrastructure setup dev stage. It actually this stage is just running a Jenkins job. And I can click on like this build number to get more information about that specific job run. You can see this orange stage here, checkpoint stage. This is one of those manual judgments. It's waiting on someone to click continue or stop. So let's go into configure, and I'll talk about how this works a little bit more. So this is like the configure view. You can see at the top, this pipeline is locked and does not allow modifications. This is something we do. We don't allow any modifications through the UI for compliance reasons. All pipeline changes go through our API and some tooling we have. Development teams have a lot of control over this, but there's certain things like at the end of this production deployment, you can see audit approval. Like you can't remove that audit approval. This is very necessary for SOX compliance for us. Developers can change things like how many instances are being deployed and where they're deployed to and what load balancers used in security groups and stuff like that. But like the core pipeline structure, we need a lot of that. But first and foremost, the pipeline kind of looks like, first there's a configuration. Configuration says what triggers this pipeline. You don't have to have one. You can manually trigger the pipeline every time if you want. But in this case, it's tied to Jenkins. It looks at this Jenkins job and gets these extra property files from Jenkins. The property file is just a Jenkins artifact. So it gets this Jenkins vars, looks at this Forest Edge job, and whenever it sees that job complete, triggers a pipeline. The pipeline takes off. First step is it bakes out our image. The bake, you can see I'm getting the artifact RPM from that properties file I passed in. I'm doing this in US East 1. I'm tagging the image just for organizational purposes, really. We have an extra web service that we run that lets you query what the base AMI should be. So our developers say should use our Java 8 base image. And this queries it so that that's not hard-coded, so we can roll that in the back end to get updates, so they just get the new base AMI whenever they do a deployment. Then we do these infrastructure setup and Git packaging. These are both just actual Jenkins jobs. It's a stage, it triggers, so like for infrastructure setup, it triggers this pipes pipeline prepare Jenkins job with this set of parameters, and then if that Jenkins job is successful, it continues down. You can configure what happens if a stage fails. In some cases, if a stage fails, that's acceptable. Maybe the whole pipeline doesn't need to stop. You send out a notification and you ignore the failure. In our cases, if any stage fails, it's a problem. Then it goes to deploy dev. Deploy is one of the magic Spinnaker stages. And this isn't just a Jenkins job. It's called a deploy stage type. And it allows you to configure what that cluster should be. It knows the context of the AMI that was built during the bake stage. So it's going to take that image that was built. For like a Kubernetes deployment, it would be the container image, the Docker image that was built. And you can do a bunch of things. So here's how you configure the deployment cluster. I tell it what account it needs to go to. You can see all of my AWS accounts I have configured, what region, what VPC subnet it should go under. What deployment strategy to use. I mentioned this earlier, of the different deployment strategy it has set up. In our case, this is just set up to use Highlander, so it'll destroy all previous server groups after the new ones passed health checks. Any production ones we use, they call it red-black because that's Netflix's colors. It's the same thing as blue-green. It'll disable, not destroy all previous server groups, and that makes rollbacks much faster. But there's an infrastructure cost associated with that because those instances stay up and running. Those disabled instances. You can do rolling deployments.
When does it eventually take them down?
You can configure that to when it should shut down. We have tooling that monitors for disabled auto-scaling groups via Lambda, I think, and it just runs every 10 minutes and sees, have these been disabled for more than 2 hours, and then we shut them down.
Okay, so if you don't have to roll back within the first 2 hours, it says you can kill the old.
Yeah. We have custom tooling that does that. I do believe that's configurable in some sense, but I don't actually know for sure. He's saying it's configurable.
We wait 4 hours and then it destroys what we have to use.
What load balancer to put them on. You could put it behind multiple load balancers if you wanted. If I click this down, you can see all the load balancers across the AWS account that was set up here at the top. So I could put it under other application load balancers if I want. You see it's got good insight into your resources that exist. Attach all my security groups. I get a full list of my security groups in AWS here. Instance sizing, pretty much anything you would need to configure with this. What availability zones, what type of health checks, user data to pass in, it's in base 64. Tags to put on, stuff like that. So you can configure, that's the deployment. So it takes the image that was baked in this bake and deploys it into a new cluster under the deploy step. Then we run a couple more Jenkins jobs just for our testing. This runs our testing jobs that against the infrastructure that was just deployed. We attach scaling policies. I think there's actually better ways to do this now. This was a legacy way we had to do it. And then it goes to the checkpoint stage. Checkpoint stage is a manual judgment that just waits for someone to click continue or stop. If you click continue, we're going to go and we're going to do this exact same thing pretty much in our staging environments. If they click stop, it just stops there, and that's the end of it. Same with and then we do that stage and checkpoint prod. After prod, we have an extra step, audit approval, where this goes out. We have a hard dependency that the person that clicks the continue button can't be the same person that made the change that is being deployed, to validate that 2 people at least have said this is okay. This audit satisfied our SOX auditors, and that's what we kind of cared about. So if we go back to the pipeline, I can click continue. You'll see it now is going back through the pipeline. If we click on custody, you can see I now have 3 instances in dev because I resized it earlier, and I can get information about each of those instances. So that's how Spinnaker looks for us. We do Spinnaker, we do AWS Lambda deployments and S3 deployments through it as well. And we have a couple different pipeline types. We've recently added what we call our rolling pipeline type. It's to try to enable Kafka and Zookeeper and these stateful applications to be continuously delivered as well. We're still working on that one. But now I'll do an actual demo of making a change, watching it through the pipeline, making a change to an application, triggering a pipeline, and watching all the way through. So here's another Spinnaker instance I have running. I actually set this one up in maybe 30 minutes following some Google Docs. If you Google Google Kubernetes or Spinnaker Google Kubernetes engine, you'll get a really great doc of getting started that Google wrote of getting started with Spinnaker and Kubernetes engine. And I just followed that guide basically, and here's Spinnaker running in Kubernetes, deploying to that same Kubernetes cluster. I have this sample app called Windy City Hello. You can see here I'm running my container image 1.8 in Canary and in a production. This is my production one running right now. You can see I have this lovely typo that I've clearly put there to facilitate a change. So let's go to my repository. We'll fix that typo. This is my application is just an index.html, and I made a simple web server with Go just to use more Google things. So I changed it. You can see I've got this demo Go. It's basically just serving the index page, and I've got a Docker file. So I have it set up to only trigger off a new tag. So let me commit here. So if I add a new tag, we'll do 1.9, and I push that tag. I push that tag to, I tried to use all Google tools for this just because it's a Google thing. So I set up Google source repository, which is what it sounds like, Google's version of Git repositories. I'm going to push my new tag to my Google source repository. Okay, pushed 1.9. You can see, and then so it pushes it to source repository. I'm using Google Container Registry using their build triggers to monitor that source repository, see that a new tag was pushed, and build a new Docker image. You can see here it's building my new image with version 1.9. So it's going to build that with my changes that I just pushed and triggered. So we'll let that build for a minute. I'll show you how the pipeline is configured. This is a much simpler pipeline, as you can see. It's configured to look at Docker registry. This is all set up within the config, but I have a one named GCR. Docker registry is a standard thing, so as long as there's some auth method, it can work with Quay.io or your own local registries. It doesn't have to be Google Container Registry. Under this organization, I look for this image, and I have regex that looks for any new images with this tag, or that matches this format, vstar, more or less. And then I take that image that was detected, and I deploy a canary. I'm deploying it to the same Kubernetes cluster, but the canary just isn't, behind the, I don't have DNS set up. In this case, canary could be going to the same cluster, but maybe not publicly routable. Or maybe you have a routing layer in front of it that routes 1% of your traffic to the canary. So it deploys this canary. You can see that this view looks a little different since it's Kubernetes setup. You can see I now have container options. I have this use none deployment strategy from Spinnaker, but uses some Kubernetes deployment strategies that are built in. It has a lot of integration with Kubernetes like that. It looks for my Kubernetes load balancers. It works pretty similarly to how it would for like AWS instances, but with like a lot of Kubernetes logic as well. I can do like container things as well. You know, what ports do I want to expose, and container volume mounts and stuff like that. So you can see my pipeline actually triggered here. You can see it detected from Docker registry. It detected a new container 1.9, and it's deploying my canary. But let me go back to what the pipeline's actually doing, just showing you the pipeline triggered. Next, I run this integration test. This integration test is another kind of Kubernetes-specific stage that kind of gets unlocked with Spinnaker, called run job. Run job will spin up a container, kind of an ephemeral container, run either your default entry point within that container, or you can override them here, commands. I'm just spinning up a container, running curl against my canary load balancer. If it exits 0, it passed. Exits non-zero, it failed. Pretty basic integration test, but a good way to the canary comes up, I run my integration test, the curl passes, it all says healthy, then I wait, promote to prod, click continue, it'll do pretty much the exact same deployment, but under my production namespace. So if I go over here, you can see my deploy canary, it took about 51 seconds. The app was actually up within maybe 5, which I'll show you when I promote to prod. But it does some like extra cleanup stuff. You can see like it monitored my deployment. The cache refresh took about 20 seconds. You can tune that all within Spinnaker configurations. It ran my integration test. That only took 10 seconds. Spin up the container, run the curl. You can see it says exit code 0. You can pass more information down as well if you need. If I go to my cluster view, you can see in Canary, I've now got my 1.8 with just one pod. But Dev is still 1.9 with one pod. Prod is still 1.8. Prod has not changed. This is my prod. I've still got my typo there. But if I'm curious what's actually under the canary, I can go to my load balancers. I can click on my canary load balancer. I can find my ingress. I can open that up. And you can see this one doesn't have the typo. That's my canary. But let's click continue to production. Continue. Should go. All right, my production is going. You can see here, so it's got the typo. Here in a couple refreshes, it should not have the typo. It deploys it pretty fast. And then it's doing that extra cleanup stuff. Oh, of course. There, now my typo's gone. So that's kind of a good process for like, you see a problem with your code, you make a change, you push it, and you can see how quickly you can get it out to production. That canary step's not even necessary. If you want to push straight to production, like that's totally an acceptable pattern. I'd say make sure you have good metrics and stuff. But that's pretty much the deployment. Yeah, any questions now?
Why is it that Netflix made Spinnaker open source? What was the whole? If it was something that was core to your business and was doing wonders for them, why is it that they made it?
So Netflix has always kind of had a history of open sourcing tools. This isn't their first. Before Spinnaker, they had a tool called Asgard. It was deprecated, and because they replaced it internally with Spinnaker, but a lot of people were using Asgard, and so from my understanding, Netflix finds value in promoting their technology as like, look how tech forward we are. We're open sourcing things, so people trust Netflix as a service more. So they open source it just to say, look how great we are at tech. If you've ever used Netflix open source tools, they can be iffy. They have a history of just like suddenly not supporting them, or deprecating them, or letting them get a date, or having their own internal fork that like has fixes so the open source one breaks. It's a problem we run into with other Netflix open source tools. Spinnaker is different, especially because like Google and Target and Microsoft are all involved with Spinnaker. It is very different than other Netflix open source tools. It has a much more consistent community deployment cycle, release pattern. They've done a good job with that.
How is Google involved with the project?
I mentioned that earlier, but Google has written all the docs. They add a lot of Google Cloud support, a lot of Kubernetes support. They wrote the CLI tool. They don't use it internally. It's just a way to promote Google Cloud. But I think there's a team of maybe 25, 30 dedicated Google engineers working on Spinnaker out of New York, I believe. Yeah.
So you in the first couple slides, you had a diagram that I was trying to parse a little bit. But are you tearing down your entire production infrastructure on every deploy? Like when you say it generates AWS infrastructure, is that generating like any new infrastructure you need, or is that literally just generating your entire all your EC2s?
So in some cases, it's not going to generate a new load balancer. We'll upsert on the load balancer.
Okay.
If they make a change to their config, we'll see that like they added a new port to load balancer, new security group, and we'll upset that, start it on that.
So it's basically diffing the infrastructure. It's not
in a lot of cases, yeah, but it will add new stuff. Like if this is the first time the app's deployed and there's no load balancer, it'll create that load balancer.
Okay.
It'll create those security groups. It'll create those IAM permissions.
Okay.
We are deploying new instances every time. Well, we're deploying a new auto scaling group every single time.
Okay.
And it'll wait till that's healthy before disabling or tearing down the old.
In your demo application, I saw that it went automated.
Yes.
Are you gonna, like if you are in production, do you use RV or like white stack deployments, or how do you?
Yeah, so that's the first time I've seen it do that. You guys got unlucky. At GoGo, since it's all behind like a load balancer and it's waiting till anything passes a healthy state before it cuts over, there's no blip at all. We don't use Kubernetes in production. I'm not super familiar with it. I don't know why that happened. But yeah, in most cases, it should wait for some healthy state before it tears down the old so that the cutover is completely blip free.
Do you only use AWS to run some of these services, or do you baseline it against Microsoft products or Google Cloud products as well?
We haven't done much. We're pretty much like all in on AWS in a lot of cases. Our SVP came from Netflix. He was familiar with AWS. He trusted it, and that kind of triggered this whole cloud thing. I think Google Cloud has awesome things. We're looking at like moving to Kubernetes. It's one of our big things this year, and how we do that's still up in the air. Whether that's Google or Kubernetes engine, or waiting for Amazon to release their Kubernetes engine. And I think it's important to note, not everything we do at GoGo is in the cloud. It is from like the ground-based services, but we're running servers on airplanes. We can't exactly run those servers on airplanes in AWS. There's no AWS Air yet. And so we use Jenkins pipelines for some of our CD stuff. We're doing CD with embedded software using Jenkins pipelines to like spin up Vagrant instances and test and continuously deploy our embedded software that ultimately ends up on the plane. We're not delivering straight to the airplane though.
So you can use Spinnaker for things like outside of even Amazon, right? Like even so just.
Yeah. Oh yeah. Yeah. You could run Kubernetes in your data center and point Spinnaker to that. Though Spinnaker definitely takes the cloud-centric view. It wouldn't be good for like bare metal deployments, unless I guess you're using Oracle bare metal cloud, which they support. I have no idea what that looks like though.
So what about Spinnaker makes it cloud-centric?
A lot of the like that deployment stage I showed, like that's built in. It makes you take best practices around like the deployment strategies. Those are all very centric to the idea that you have a scaling group. You don't just have an instance that you're rolling. You have a scaling group that you've deployed that handles all those instances rolling. Things like you don't have to put it behind a load balancer, but it's all built in nicely with that. OpenStack, I guess, solves the local data center issue as well. Like OpenStack is cloud software as far as I'm concerned too. And you can deploy like to your local data center using OpenStack. Target built all the OpenStack stuff. They love Spinnaker, but they have a lot with OpenStack, so Target put a lot of effort into building out the OpenStack stuff. And I've heard it's great if anyone uses OpenStack.
For this continuous integration and figuring out if so I'm not sure if most of this is developing graphical user interface software, backend software, but I guess what in your opinion of when you've been working with this, what do you like to use as for testing, like Google Test or something like that?
For like the actual testing of the applications?
Yeah.
I don't know. We have this whole quality engineering department that handles a lot of that, and I'm not sure how they do it, to be honest.
So it's not part of the continuous integration?
Well, it's part of the pipeline. Like they write the jobs, they sit next to the application developers. They're very tightly integrated. But I'm on the DevOps team, and from our perspective, we don't really care about runs. Here's a spot in the pipeline to run your jobs. You don't actually have to run anything. Some of them you will see have empty pipelines. I think it's a bad pattern. But we don't force that on a development team. If they don't want to run tests, they don't have to run tests. But it's very much a supported part of the pipeline from the very beginning. And if the quality teams want to inject their tests before going on to the next thing, they can do it however they want to run those.
Did you guys ever experience like kind of core CI, like continuous integration, continuous development? If you did, do you guys see, I mean, how much gain did you, like, in terms of, like, I would say, I hate to say velocity, but velocity.
Yeah, so there's a chart I meant to include in my slides that I've done in other talks that show some metrics on that. We are doing maybe 5 to 10 deployments a month prior to having anything like this across all of our applications, and now we're doing 5,000. And the outages that we've caused due to a deployment have gone down 3-4-fold. Every once in a while, a continuous deployment does cause an outage. We're not saying this is some perfect solution to not having outages, but if it's so fast and you've got good metrics and you've got this good testing system along the way, catching the outage before it gets to prod is much simpler. And we've caused 3 or 4 outages, I think, since we've started doing this.
Do you see increased velocity and quality?
Yes, absolutely. Yeah. And our system is entirely self-service from the application teams. They don't need to come talk to DevOps in any capacity to deploy, or to even set up a new application. We wrote a tool called Foremast. It's open source if you want to see how it works. But they basically have some configs that say, this is what I need my environment to look like. They bundle it in their applications repositories. If we see any changes to those files through Git hooks, we generate out the pipeline, we set up the triggers through tooling, and their application deploys. There's absolutely no need. I mean, they talk to us if there's new use cases, but for like a new app that follows most of our standard practices, they don't need to engage anyone but themselves. It's as self-service as we can make it, really.
Are you, when you're using Spinnaker, do you find that there is still a lot of bugs in it? Are you actively contributing to the source code changes in it, things like that, or you're using it from deployments or
So a year ago, I would have said I was finding bugs in it. We have a couple contributions to it, nothing too major. I think Joel, one of the organizers of this event, actually has like 3 or 4 smaller contributions. But I'm sorry, we're going over. But no, nowadays no bugs. Like, it's a very stable deployment system, and I've been disengaged with the community because it's been so stable lately. All right, thank you, everyone.
Thank you.